In an Egyptian mural dated to roughly 2500 BC, a servant kneels beside a large clay jar and fans it, over and over, for no reason that looks obvious at first. The jar isn't on fire, nothing is cooking inside it, he is fanning water. That single image, painted during Egypt's Old Kingdom, is the oldest surviving evidence of a machine built specifically to fight heat. And it worked on the same principle used by cooling systems today, 4,500 years later. For most of human history, staying cool wasn't a machine problem. It was a body problem first, then a wind problem, and only much later, a math problem. Start with the body, because the body got there first, by about 2 million years. Modern humans carry somewhere between 2 and 4 million sweat glands, a density unmatched by any other primate. Harvard evolutionary biologist Daniel Lieberman, working with researcher Andrew Best, has traced this trait back to early hominins moving out of shaded forest and into the open, hot savanna of East Africa, where the ability to dump heat through evaporation, rather than panting, like most mammals, became the difference between surviving a midday hunt and collapsing from it. A 2021 study, published in the Proceedings of the National Academy of Sciences, went further, identifying the exact genetic switch responsible, a mutation in a skin development gene called ingrailed-1, which quietly rewired the human body over hundreds of thousands of years into what researchers now half-jokingly call the sweaty ape. Before there was a single tool, a single building, a single idea about architecture, evolution had already installed a cooling system directly into human skin. But biology alone has limits. A body can shed heat, it can't cool a room, a city, or a harvest. So what was the first fix once humans started living in fixed structures instead of following the shade? The answer shows up in Egypt by 2500 BC, in exactly the mural described a moment ago. Porous clay jars, made from Nile Valley marl clay, sweat water through their walls the same way skin does. Fan air across that surface. And evaporation pulls heat out of the jar and out of the surrounding air along with it, a technology later called a zir, still used in parts of North Africa today. It was crude, it required constant human effort, and it barely dented the temperature of an entire home. Someone, somewhere, needed a version of this that didn't need a servant standing there all day. That someone appears to have lived in Persia, somewhere between the 10th and 13th centuries, with some architectural historians tracing the underlying concept back nearly 2,500 years to the Achaemenid period. Persian builders started raising tall, hollow towers above their houses, called badgers, or wind catchers. Nazar Rabat, director of the Aga Khan program for Islamic architecture at MIT, points out that the towers didn't need a person operating them at all. They caught moving air at roof height, funneled it down past shaded, sometimes water-cooled channels, and released it into the rooms below, drawing hot air back up and out through a second shaft. Engineer M.N. Bahadori documented the physics behind this in a 1978 paper in Scientific American, showing that a well-built wind catcher in the desert city of Yazd could lower indoor temperatures by close to 10 degrees Celsius, with zero electricity, zero moving parts, and zero fuel. Here's the part worth sitting with. Modern architects studying sustainable cooling today are copying a design that predates the light bulb by well over 1,000 years. So the body cools itself. Buildings cool the air around bodies. Was that the end of the story? Not quite, because neither one could do anything about food. Meat spoils, fruit rots. And in a desert where summer temperatures regularly cross 40 degrees Celsius, keeping anything cold for months at a time looks, on paper, almost impossible. Enter the Yakchel, a beehive-shaped ice house that Persian engineers were building as early as 400 BC. On the surface, it looks like magic, a dome of insulated clay rising out of open desert, somehow holding solid ice through the hottest months of the year. It wasn't magic. Engineers exploited a physics gap most people never notice, that a clear night sky, even in a hot climate, can radiate enough heat away from a shallow pool of water to freeze it, hours after sunset. Shallow basins near the Yakchel were flooded at night, and thick, shaded walls, sometimes fed by underground Qanat channels, kept the resulting ice from melting come morning. A 2023 engineering review of the structures, published by researchers Pochi and Gunstone, confirmed the same radiative cooling principle used in some experimental sustainable cooling systems being tested right now. Multiply one clever trick like that by centuries of trial and error, and an entire desert civilization ends up eating frozen desserts in a place with no winter to speak of. Which raises the real question underneath all of this. Was there ever one solution? Not really. There were three separate ones, stacked on top of each other. each one plugging a hole the last one left open, the body's own chemistry, then a wind catcher's physics. Then a Yakchal's exploitation of the night sky. Modern air conditioning, invented in 1902, gets credit for solving heat. It didn't. It just replaced 3 separate low-energy inventions with one high-energy one. And for most of human history, on the hottest days on Earth, none of that electricity was needed at all.